right, so to do this one, right, we need to get this into y equals mx plus b form. All right, so this is called slope-intercept form because it gives us the slope m and it gives us the y-intercept b. So here my equation is written as 2x plus y equals 4. So what I'm going to do is I'm going to go ahead and solve for y. So I'm going to get y equals, I'm going to subtract the 2x. Do not add it with the 4. What that's going to do is that those are non-like terms. Can't do that. So I'm going to start with the y-intercept of 4. So not that one, not that one, not that one. I have a slope of -2. This one has a slope of +2. So my answer is going to be A, -2. All right, let's go ahead and take a look at the next one. Starting off with a little bit of, the different ones today. I got a couple hard ones. I'll save for a little bit later. So, number 36. Which of the following figures in a plane separates it into half planes? All right, this question is not great. It's kind of dumb, to be honest. You have to read it multiple times to be like, what is it even talking about? So a plane is literally just like a three-dimensional flat space that goes on forever in all directions. All right. So it's kind of like a piece of paper that goes on forever in space. So it says, what of these figures would split it in half? Okay, so the figures that would split it in half. It only can split it in half if it goes on forever. Okay, and the only one of these that goes on forever is forever. Okay, and the only one of these that goes on forever is a line, F. Okay, a line is the only thing that goes on forever. So what splits it into half plane? That would be a line. All right, here we go. We're doing ACT prep here. We've got a lot of students taking it in March. A lot of people haven't done math in a while. Some people got college and introduction tests or whatever they call that right before they get in. So good to have you. What is the maximum number of distinct? Distinct, another word for that is unique. Okay, another unique diagonal. So what is diagonal? A diagonal is simply a segment where we start at a vertex here and we go ahead and connect it with another vertex. So if I'm here, I go ahead and I connect it over here. That would be called a diagonal, right? A lot of times when we buy TVs, right, they say, oh, this is a 40-inch TV. Well, that 40-inch TV is measured in a diagonal, corner to corner. So if I'm looking at this, problem 37 here, distinct diagonals, I'm going to go ahead and draw all the different diagonals that I possibly can. So there are 3 in green. All right, so there's 3 in green. Now let's go ahead and move over to another vertex, let's say here, and then I'm going to go ahead and draw 3 more distinct, aka unique, diagonals. All right, so I'm at 6. Let's see if I can make it 9 or if we're stuck at. So if I'm here, I've already drawn that one, so I could draw that one or that one. That leaves me at 2. If I'm here, looks like I've already drawn that one, All right, I'm going to go ahead and draw right here. So that's going to be one more. So my total is D9. Like, come on, like that. I know it's an ACT and like it's checking on different things, but that's kind of a dumb question, to be honest. Okay, kind of a dumb question. But an easy one at that if you know what a diagonal is. All right, so let's take a look at this top problem. This one is difficult, very difficult. In the figure below, ABCD is a square. Points chosen on each pair of adjacent sides to form 4 congruent right triangles. Okay, so each of these triangles here are right and they are all congruent. All right, so what we have to do is we have to figure out what fraction of the area of the square is shaded. I guarantee you that this question, less than 10% of the people got this one right. All right, this one is definitely the trickiest one we've seen so far. So what I'm going to do is I'm going to go ahead and I'm going to figure out what is the side length of this figure right here. Okay, what is the side length of this hypotenuse? Because if I do that, then I can find the area of the square, because it's just side by side, right? Side times side. So if this triangle right here is x and 2x, then I can use Pythagorean's theorem, which just says if I have a right triangle, I have a squared plus b squared equals c squared. A is one of the legs, b is the other one, and c is my hypotenuse. So I'm going to have x squared plus 2x, make sure you put that in parentheses, because if you don't, you're going to screw that one up, equals c squared. So if I've got x squared plus 4x squared, that's going to be a huge issue. A lot of people are not going to square that too. Equals c squared. So I get 5x squared equals c squared. And then I want to go ahead and I want to square root both sides. So what I'm going to get, and I'm going to end up getting the square root of 5, and then the square root of x squared is just x. So this right here is the square root of 5 times x. That's the length of that side. You with me? You haven't checked out yet? So what I'm going to do is I'm going to find the area of that square. So the area of the square is the square root of 5x times the square root of 5x. Zadowski, good to have you. This is the toughest problem that I've seen so far. All right. So we've got 4 equal right triangles. We got to go ahead and figure out what fraction of the area is the square compared to the entire square. So the shaded square compared to the whole square. So what we did was we said, all right, this is a squared plus b squared equals c squared. We got the square root of 5x. And then we're going to find the area of this square, which is square root of 5x times square root of 5x, which ends up being 5x squared. So now what we got to do is we got to compare that to the area of the entire square, which is 2x plus x. So that's the area of one side, or the length of one side. We have to square that. So that gives us 3x squared. So when we go ahead and figure that out, we get 9x squared. So if we get the big one, the large one being 9x squared, and then the small one, the shaded one, is 5x squared, we go ahead and we see that 5/9 is our answer. 5/9 in our answer. Definitely the toughest one we've done so far. As you continue doing this, these will not be tough for you. You will dominate. All right, let's take a look at number 34. Number 34, it says, a surveyor took and recorded the measurements shown in the figure below. If the surveyor wants to use these 3 measurements to calculate the length of the pond, which of the following would be the most directly applicable? So, taking a look at this, if I want to find this length, I'm not going to use Pythagorean's theorem because you need a right angle to do that. So Pythagorean's theorem is out. Next, I'm going to go ahead and I'm going to, the formula for the area of the triangle. No, unfortunately. I mean, we're going to use Heron's theorem. Okay, I'm not going to really use that. The ratio for the side length of a 30, 60, 90, 40, 45, 90, those are important, especially when we get in the unit circle, but unfortunately, those aren't going to be what I'm going to use. I wish they would have had the law of sines on here, because the law of sines could have been a good contradiction to the law of cosines. The law of cosines is used if you have 2 sides and 1 angle of any triangle, but you don't have the corresponding side across from the angle you're given. That's when we would use this formula right here. That's called the law of cosines, used when we don't have one side across from one given angle. So the answer here is K. All right, halfway done. Nobody is here. And you know what? That's when champions are born. So I'm going to keep rocking on. All right, let's take a look at number 38. Equations of a circle. Equations of a circle. So the standard equation of a circle is x minus h squared plus y minus k squared equals r squared. All right, so the center of our circle is centered at HK. radius is r. Our radius is r. So if I go ahead and I take a look, this looks like the x value is 4. The y value is 0. So I'm going to have x minus 4 squared plus y minus 0. So I'm just going to have y squared equals my radius squared. It looks like my radius is just 4, so that's 16. All right, Aubrey, good to have you. So this is the this is the circle equation that I'm looking for. And that looks like it is going to be G, letter G. All right, we got a few more here. Let's take a look. All right, number 39. Number 39, this one's a little bit tricky. All right, they give you 4 fractions. They want you to put it in order. They want you to put it in order. So my suggestion to you, if you have a good calculator, you need to have a good calculator for this. We're going to put all of these in our calculators. If you have a TI-84, like I keep telling you to get, you can press, oh, you see my light there. You press alpha X, and that allows you to put the fraction in. So I'm going to put in 5 over 3. All right, and it's going to give me the answer of a fraction. But if I go ahead and I write math, I push math, and then decimal, it gives me that as a decimal. All right, so that makes everything much easier. So 5 over 3 is 1.6 repeated. Now I'm going to do the same thing with 7 over 4. So I'm going to do 7 over 4. All right, and I'm going to push that into a decimal. 1.75. So it makes it a lot easier to compare. I obviously know this one's going to be bigger. You can also get everything in common denominators, but who wants to mess around with common denominators? Seriously. So I'm going to do alpha x 6 over 5. That is going to give me a decimal. Oh, first math here. Oh, don't want to do that. I'm going to go math, decimal. I'm going to get 1.2. So 6 over 5 is 1.2. All right, and then I'm going to go ahead and do 9 over 8. 9 over 8. That gives me an answer of 1.125. So if you don't have this calculator, make sure you get it for your ACT or get a friend to give one to you. So if I go ahead from increasing size, so from smallest to largest, smallest is 9/8, so it goes 9/8, 6/5, 5/3, 7/4. 9/8, 6/5, 5/3, 7/4. A calculator problem. Get a calculator you know and you love. All right. Oh, look at how long this question is. This is a question 50% of the kids just skip because they just look at it. All right. We're not going to do that. We're going to dominate. It says, Mai is putting gold foil around the outside of an elliptical picture frame. Why do they even need to preface that? I mean, we all know nobody is doing that, especially Mai. The perimeter of an ellipse is given by the formula, blah, 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 where h is the height and w is the width. As shown in the diagram below, if an elliptical frame has an outside height of equal, okay, blah, blah, blah. So they tell us that this is 4, and the width is 3. Go ahead and find the perimeter. So this is all I'm looking for, my perimeter formula. So my perimeter formula is pi over 2 times the square root of 2 times, all right, my height squared. So that's just 16, 4 squared, plus my width squared, which is 3 squared, which is 9. All right, this is going to give me, the perimeter is pi over 2 times the square root of 2 times 25. All right, I'm going to keep rolling with this. I've got pi over 2 times the square root of 50. All right, here's something that students struggle with a ton. Square root of 50. So the question is, what do I know the square root of that goes into 50? All right, so I know the square root of 4, I know the square root of 9, square root of 16, 25, right? So which one of these goes into 50 evenly? Yep, and that would be square root of 25. So if I go ahead and I split this off, I have the square root of 25 times the square root of 2. This square root of 25 becomes 5, and then I'm left with root 2. So my perimeter is pi over 2 times 5 2. All right, so my answer is 5 pi over 2 root 2. So that is letter F. All right, don't be one of those people who skips this problem just because it's got a ton going on. All right, take a look at 41. 41, I don't know about 41. This one is, I feel like they're just really trying to trick you. ACT, math nerds are in the bag here trying to like, how can we go ahead and trick these kiddos? All right, it's A over 30 plus B over 105. Okay, blah, blah, blah. So basically, what they're doing here is they're showing you that I want to get common denominators here. I get this. So they're basically showing you I multiplied this A by 7. If I multiply this 30 by 7, what do I get? 7 times 3, 21, and 210. Okay, so if this was 7A, then this would be 210. All right, plus 2B. Okay, or not 2B, that is the question. All right, so if I put a 2 here, then I'm going to double 105, 210. So does X equal 210? All right. Not a hard question, but like if you don't see it, you can't get it. I mean, that's what happens here. All right. ACT tries to trick everybody, and then they feel like we've got the best test in the world. Pay for our testing services. Nobody can show how smart kids are like we can. All right, let's take a look. Kaylee is planning to purchase a car. Unfortunately, her math teacher didn't teach her anything about interest rates, so she was given this chart by the dealership. How nice. She will need to borrow some money. The chart is given to her how much her monthly payment is per thousand. I can tell these amounts were not given any time lately, probably in the early 2000s, all right, when the economy was good. Kaylee found a used car. She was thinking about purchasing. The list price is $8,000. Has anybody here ever seen a car for $8,000? Not anymore. She calculates that she will need to borrow $6,500. Okay. Approximately what would her monthly payment be if she borrowed the money for 36 months at an annual interest rate of 10%? So 10%, 36 months is $32.27 per thousand. All right. Well, I'm going to go ahead and borrow only $6,500. She's got a decent $2,200 down payment. Okay. Probably working at what? KFC. All right. $32.27 times 6,500. Excuse me, this is not 6,500. This is 6.5 because it's per thousand. Okay, so don't make that mistake. 32.27 times 6.5. I get 209.76. 209.76. Letter H. Letter H. Now let's take a look at 43. So a local dealership is having an end of the year model clearance where everything's 5%. All right, so we're looking up here at 5% right away. On a new car loans for all the months, the maximum amount Kaylee can budget for her month is $300. Of the following loan amounts, which one is the maximum Kaylee can borrow at 5% annual interest and stay within her budget? Okay, so she's probably going to want to do the 60 month if she wants to max out her budget. So I'm going to take this $300 budget she's got, all right, which is probably double today, and divide it by the lowest per thousand at that interest rate, at that payment schedule. Okay, so I'm going to do 300 divided by 18.87. So 300 divided by 18.87. I'm going to get 15.89. So that would be 15.89 thousand. Okay, 15.89 thousand. So my answer is D. I can afford about 15,000. All right. All right. Last one. Here we go. Another dealership is offering a 5-year loan with a 9% interest rate. Okay, what's interesting about that is if we take a look up here, we don't have a 9% interest rate. Okay. Kaylee uses her chart to estimate the payment per thousand of the following, which is most likely the monthly payment per 1,000. Remember, it's a 5-year loan. So how many months is a 5-year loan? All right. If you're not good at multiplying in your head, 5 times 12 is a 60-month loan. All right. So what we got is we got a 9% loan. So 9% is going to be between, not 10 and 12. Okay, that's going to be between 8 and 10. So 8 and 10% is going to be 9%. So what we're going to do is we're going to split the difference. All right, we're going to go ahead and take 21.24, and we're going to subtract 20.28. All right. We're going to divide that by 2. That gives us the difference, and we're going to add it back to 20.28. That gives us $20.76 for 9,000. So as I look down, I get $20.76. All right, thank you for sticking around. Math Be Real.